Hi everyone, welcome to the HILT CRC webinar today. Today we're talking about analysis of market and export opportunities for green iron and steel. And this is one of our public webinars. So we've got a large amount of attendees registered today. So we'll just see as everyone trickles in now. So my name is Jenny Selway. For those of you who don't know me, I'm the HILT CRC CEO. And I'd like to kick off just by acknowledging the traditional owners of the land. So I'm sitting in Melbourne on the traditional lands of the Wurundjeri people of the Kulin Nation. I'd like to pay my respects to elders past, present and emerging, but also extend that to the traditional owners of all the lands that we're dialing in from today. So HILT CRC, just briefly, in case people are not familiar, we're a cooperative research centre that's de-risking and accelerating decarbonisation for iron ore, steel, alumina and cement. And we do this by linking industry, research and governments on local, national and international scales. So we currently have over 60 partners and we're growing all the time. So very interested and keen to meet new people that are interested in HILT as well, who'd like to join our collaborative ecosystem. So we do a lot at HILT, but first and foremost is our research programs. We have 3 different research programs, first one being process technologies, so the really technical part of decarbonisation of those sectors. Another program called cross-cutting technologies, that's focused on everything that's common within the sectors and a lot of energy-related research in that program. And then finally, we have facilitating transformation, our program 3. This is the program that looks into regulatory, policy and market-driven factors. And today's webinar looks at 2 projects in particular from this facilitating transformation program. I'd also like to introduce our research director, Professor Gus Nathan, and I'll pass over to him now to introduce the speakers and go over the agenda for today.
Thank you very much, Jenny, and I would like to add my welcome. It's great to have the opportunity to engage, and we're looking forward to the opportunity to people who reach out to follow up. As Jenny mentioned, we have those 3 programs, but also it's worth noting that each of those are heavily interconnected, and the further we go, the more that the technical aspects feed into the analysis of policy and markets, and both Frank and Jorrit will touch on that, and we look forward to opportunities to build in that collaboration as the HILT extends, including with international partners. So firstly, it's my great pleasure to welcome 2 speakers. Firstly, we have Dr. Jorrit Goossens and also Professor Frank Jotzo, both from the Australian National University. And Jenny will flick to the next slide, which also shows a bit of their profile. I won't go through them in detail, but I'll highlight a few points, but I'll also mention that their details are also on the publicity and the web link, so feel free to browse in that in more detail. So Frank is Professor of Environmental and Climate Change Economics at the ANU Crawford School of Public Policy. He's done a huge amount of advising to public policy, and including nationally and around the country. And Jorrit also is doing a fantastic job as a fellow in the same centre and institute, and is doing a lot of the detailed analysis. And so first of all, I think I'll hand over. I'm pretty sure Frank is speaking first, although the order was different. No, Jorrit may be speaking first. So I'll hand over. They're both going to speak for around about 12, 13 minutes. Then there's going to be time for discussion at the end. So if you have any questions, please type your questions into the chat box, and then we'll have lots of time for discussion down the track. Thank you. So over to you, I think, Jorrit.
Yes, that's right. And I'll just quickly grab my slides. It should be them there. So a few slides to introduce the discussion for today. I think both my and Frank projects really talk about sort of the prospects of Australian exports of either iron ore or green iron into global value chains. For my project, and specifically, we've done some modeling of the economics making that possible. And so first to sort of explain the whole thinking there, for those that are not aware of this thinking. Currently, Australia exports mostly iron ore to China and to a number of other countries in the region. With the switch to green iron making or green steel making, the hope is that we could have more of the downstream processing happen here in Australia. So we could use our very high quality renewable energy resources to do some of the iron making in Australia and export that to China, or possibly steel making and then export the steel to China. That's the thinking. Some of the processes mentioned here, already a few acronyms in there. I'll assume that not everyone is across that. So I'll be very brief, but with enough detail, hopefully to understand. There's basically 3 routes, production routes for steel that we're investigating. The first one that is included in our model, the first one is blast furnace iron making, which is the conventional method of iron making. So that's with coking coal and very emissions intensive. We try to get away with that from that. The good thing about this process, however, is that it's very highly suited to the use of Australian ores, including the Pilbara hematite. For green steel making routes, we have what is somewhat conventional already, the DRI making step, so direct reduced iron making, and then putting that iron through an electric arc furnace or EAF. That's currently mostly a process for the recycling of scrap. In the future, we will see more use of green iron through that process. It does require a very high grade of iron, so very few impurities. That means you need to start with a very low or high grade iron ore if you use the DRI EAF pathway. There's also a competing pathway with the electric smelting furnace in between. That electric smelting furnace has the benefit of melting the iron and the impurities, and therefore making it able to separate the two very efficiently. That iron can then also be used in either a BOF or an EAF because it is very high purity after melting. That is also very suited for low-grade Australian ores. So those are the sort of routes that we consider in our modeling. Then, and this is somewhat technical, so I'll really just say what we've done is we've modeled this in an optimization model. What we try to do is find the least costly way to supply all of China's demand for steel. So we look at the cost of production in mines, of processing steps, of transport, etc. The theory is that replicates real-world markets, and usually the finding is that at least if you calibrate these numbers correctly, it does replicate real-world markets quite well. I think what's interesting about our model compared with a number of other models on the same topic that have already come out is that we have quite good detail on basically the process model. So our colleagues from engineering have helped explain how does the consumption of energy, of hydrogen, the consumption of flux, etc., how does that depend on the composition of the iron ores? And we look at a number of qualities in that iron ore. We think that that is very important, again, in particular for those low-grade Australian iron ores in its competition with higher grade ores from Australia and elsewhere. These energy and flux consumption numbers, etc., will be different, and therefore it's important to get that calibration correctly. We've done that, we've included all of that, and we consider that in the costing of the final cost of a ton of steel produced via each of these ways. In terms of pathways then, so I've already given sort of the overview a little bit graphically, but just to reiterate, the technological pathways included in our modeling include so the conventional ways of making steel via the blast furnace and then the basic oxygen furnace, also DRI making steps and electric arc furnace, scrap consumption as well there. And then a number of green production processes that has more or less of the process occurring in Australia. So that would be the blue bits happening in Australia, the red bits in China. So either via the electric smelter furnace with exports of pig iron to be consumed in Chinese ESF or BOF or electric arc furnaces. Alternatively, turning it into hot briquetted iron and consumed in China. Or we also look at this, the possibility of steel exports. I can already say in no scenario does that happen, in only ever is any export of iron. So then we run the numbers and we ask the model, basically, given all of the production costs that we know of in the iron making step, the mining, the steel making step, etc., what does the production cost of green hydrogen need to be in Australia and in China in order to make the production of green iron in Australia a competitive suggestion? So how cheap does Australian hydrogen need to be versus Chinese hydrogen in order to have any iron production occur in Australia? And what we find is that if we say, if we use exactly the same costs in China and Australia, then the model tells us, and we look purely at the Chinese market here, that the supply of iron in China would be about 3/4 from domestic sources. So that doesn't need to say that it's domestic iron ore, just means that it's the iron production that happens in China, and a good bit of imported iron from Brazil and Chile. So if Australia does not manage to produce hydrogen at a cost lower than what it is produced at in China, our model says that it's unlikely that Australia will export any green iron to China. But then we start to move that slider and say, well, what if it's a bit cheaper or a lot cheaper? And so that's all these different numbers here. And really the big message coming out of this modeling is that if we manage to produce green hydrogen at just $0.50 cheaper, half an Australian dollar cheaper than what it costs in China, then we will have a competitive production of very vast amounts of iron in China, about in Australia, about 400 million tons of iron could be produced in Australia at that cost differential. After that, there's some increase, but really that's the number to keep in mind. That's where it all switches on quite quickly. A second key important lesson from our model is if we look at those different pathways again, with the electric smelter furnace versus the electric arc furnace production route, really, or from DRI straight into electric arc furnace. We've asked the model, if you had every opportunity, so no restraints on the choice, how would you process the Australian and other iron ores? And this is what we get. So what we see is that pretty much the blue stuff is Australia. Pretty much all of it, just a few percent isn't. Pretty much all of it is processed via that smelter furnace pathway. Really, the only ores that do not get processed via that pathway are ores from Brazil, a little bit from China, and some rest of the world would be either Russia or Guinea. So this already gives you a good idea that the model says most economic pathway for processing Australian ores is via the smelter furnace pathway. And so clearly an important technology to develop. And again, we've run some scenarios with this. So we asked, or we tell the model, suppose that global smelter furnace capacity is either very low all the way to very high. What would be the consumption of Australian iron ore in that scenario? So this is not about the location of iron production, as in my past or the previous graphs. This is about what is the origin of the iron ore that is consumed for green steel making, whether that happens in China or wherever. And again, we see very much the relevance of the smelter furnace to the consumption of Australian iron ore. If there's very little smelter furnace capacity, we see very little Australian ores consumed. Basically, all the market share is taken up by Brazil, Guinea, and rest of the world. So again, that would be mostly Russia and some other Latin America. Right about the 300 to 400 million tons of electric smelter furnace capacity is where sort of the optimum level for Australia would be. Then we would see a pretty good amount of Australian iron ore still consumed. So really, in summary, those two lessons really is what I wanted to share from our model exercise today. One is that the relative hydrogen production costs will really be what drives where green iron is produced. And we find that Brazil and Chile, maybe other Latin American countries, seem to be quite competitive versus domestic Chinese production. So we should expect those countries to be supplying green iron to China. For Australia, there needs to be a cost gap created in the cost of green hydrogen production of about $0.50 or more, half an Australian dollar or more. And so it's up to either very cheap renewable energy project development costs or something like a subsidy like the government is currently suggesting with the hydrogen production tax incentive to create that gap. Second lesson, the electric smelter furnace, which is in pilot stage right now, is going to be crucial for Australian export, the outlook really. And then we're talking about the iron ore, not necessarily the production of iron. We're talking about how much iron ore will be consumed in those green steelmaking pathways. So we find that basically the consumption of iron ore from Australia in green steel pathways scales pretty much linearly with global smelter furnace capacity, because the processing of Pilbara ores is quite uncompetitive via the conventional EAF pathway. That might change a bit still with other beneficiation technologies, but that's what we believe at this point. And that really gives a strong incentive for both Australian government and industry to promote the development of that technology, whether it is used in Australia or whether we get our Chinese customers to build these smelter furnaces. Getting those plants up will be very important. And then I have one more slide just to sort of look into the future a little bit. In terms of model development, we still have a few things to do. Right now, the model is completely focused on China. We'll aim to expand that to other global markets. And we need to have within China, or within Australia, I should say, we would need to look more at more local hydrogen production costs. We know that these vary quite a bit between the Pilbara and other locations. In the future, what we still hope to do with this model is sort of quantitative policy evaluation. So trying to figure out if we have a hydrogen production tax incentive, what is the or optimal level, how are CBAMs, etc., going to affect the Australian outlook. This model is really very suited to answer exactly those kind of questions. And sensitivity analyses. So some technologies, some costs may still develop in the future. We're not sure how important they are in determining the final answer that we're interested in, which is how much iron will we produce in Australia and how much iron ore will be consumed from Australia. So that's the few points I had for today, and then I will hand it over to Frank.
Thank you very much, Jorrit. That was an excellent presentation. Please, if you're online, join me for an online clap. That was fantastic. And I'll just make a couple of general comments before handing over to Frank. The first is just to remind everyone that HILT is actually a 10-year program, and we're about 2.5 years through. We have a technology agnostic framework. So in terms of some of the general comments, we do plan to keep exploring other options and pathways as more information goes forwards. Also, Jorrit will be happy to have a few brief online responses. Feel free to bring them in and we'll pick up another discussion later on in the question time. So thanks again, Jorrit, that was great. Now I'll hand over to Frank. And Frank, please, you also introduce your title, etc., and over to you. We're looking forward to it. Thank you very much.
Sure, yeah, thanks very much, Gus, and thanks, colleagues, and thanks everyone online for your interest. It's really appreciated, and I think it's a sign of just how big a topic this actually is, green iron and Australia's opportunities in the world. Now, what we're presenting here today is really on just to drive that point home, a sort of a slice of the research that's done on these topics, both on the economics and supply chains and policy analysis, as well as, of course, the engineering and technical analysis that's done at a number of project partners universities, including ANU. I will give you a really brief kind of overview of some highlights of a batch of reports and papers that will be finalized very soon, and so you're getting a bit of a sneak preview here, and I'm sure that will be fodder for the discussion as well. I already see the many questions for Jorrit rolling in. Look, this work is of course part of a broader portfolio of work on green iron and steel that we're doing here at ANU, and importantly also to acknowledge the partner universities that have contributed to the research of which I'm presenting highlights. I will not name individual contributors. They will all be on the reports and papers, just to say that University of Adelaide, Swinburne University, and Queensland University of Technology actively contributed to different aspects of the research that I'm presenting. So I'll focus on some results that I think will be of interest from a largish expert elicitation exercise that we did for this project, teasing out expert views in interviews, right? This is not just sort of internet-based, but these were individual interviews with people who know what they're talking about on green iron and steel in Australia. Then a few words on demand scenarios and possible sources of demands, a bit on scrap recycling, and I'll spend a little more time on our analysis of the features of policy instruments that can be used to support green iron and steel. And once again, just a few highlights here. The underlying work is really quite extensive. So the expert survey, one of the key questions here, and something that exercises a lot of people in this community, by when would it be that we expect we'd be at commercial scale of production of green iron and or green steel in Australia? And yeah, if you summarize the gist of the responses here, is really in the 2030s that the bulk of expectations are for commercial scale, which we defined as greater than 1 million ton per year, both for green iron and for green steel in Australia. And then, a slightly earlier expectation for green iron from magnetite than from hematite probably doesn't surprise anyone in this community. But overall, really notable, I think, that the bulk of expectations here are for this to occur already in the 2030s rather than the 2040s and beyond, which, frankly, would have been my expectation when I started work in this field maybe 5-7 years ago. What about the importance of local factors for the location of a green iron or green steel industry in Australia? So this is locational factors, is it in the Pilbara, is it in South Australia, is it in Queensland, is it somewhere else? And like with other questions of this nature, what we saw is that really a whole number of factors that we put up for testing in our expert elicitation came up as important, but one or two stood out head and shoulders above the other factors, right? And in this case, it was locational factors. It's really availability and cost of renewable energy, right? And that comes back directly to the factors that are present in the modeling that Jorrit has developed, right? It really comes down to the energy cost, which is, of course, the key driver for green hydrogen costs. And so that comes through very clearly as well. But many other factors judged as being very important as well, such as local laws and regulations, type of iron ore availability, proximity to infrastructure, etc., etc. Further down the list, interestingly, labor costs. Okay, not in among the top items mentioned as important local factors. What about obstacles for the emergence of a green iron industry? And note, this is only for green iron now. I'm putting much more emphasis on the green iron side than the green steel side. All of this is replicated for green steel as well, which you will see when the report comes out. And the two standout factors identified in expert elicitation here are government support, government funding, and capital costs, right? So high capital costs in Australia and a perception that perhaps there is a relative dearth of government support relative to other jurisdictions. That, of course, is changing and indeed has changed since the time that we conducted this survey. So if we conducted a survey again now, the answer to that might well be different when we frame that question as an obstacle. What about enabling measures? So on the other side of the coin here, what makes the emergence of a green iron industry possible in Australia in future decades? And the two standouts here mentioned by experts are carbon pricing and border carbon adjustment measures. Now, border carbon adjustment goes two ways, could be domestic, could be internationally. If there's a carbon price and a border carbon adjustment in a country that has a steel industry, then that very much gives an opportunity for Australian or other country-based green iron producers to supply into that market and actually harvest the green premium that will be available in those markets where carbon price exists and where that carbon price is extended to international trade markets. Okay, many other factors, and you can see them on the list here. And perhaps interesting to note what's further down the list, things like assistance for regional communities, government procurement, public R&D, all judged as important, but nowhere near as important as carbon pricing, as well as some other factors such as tax rebates, certification schemes for green iron and steel, etc. Very happy to go into more detail on all or any of this in questions later on. Now, what about demand? Firstly, which product categories do experts see demand arising in first and dominantly? And really here the car industry is head and shoulders above everything else. And you can see why, right? So steel, fair bit of steel in a typical car, but of course as a share of total cost of a car, it's minuscule. And so the additional cost of using green steel in a car is really, really small compared to the sales price. And of course it's consumer good, including one that exists in luxury markets. And so you've got a clear opportunity here for lead market in the automobile sector. Secondly, domestic appliances and renewable energy systems, right? So you have an obvious case here, for example, with wind turbines, for some providers to potentially pay a premium for green steel in order to make a valid claim to an even lower carbon total supply chain of renewable energy. Domestic appliance, similar arguments goes for the car industry, whereas the bulk markets in construction and infrastructure are expected to go much slower in terms of uptake of green steel. Which markets go first? Well, probably no surprises here, the developed country markets, Europe, North America, as well as East Asia, and Australia potentially as well. Tiny market, of course, doesn't matter too much. But yeah, so pretty much expectation that uptake of green steel may go in line pretty much with economic development. Out of that and out of some projections for scrap recycling and more broadly circularity in materials use and steel use, we can construct some scenarios for aggregate green steel demand in the bulk of the world economy. I've listed them below. This is, of course, highly speculative, right? The main point of showing these numbers is that depending on the overall green steel share, which we're extrapolating from the survey, and importantly, depending on the degree of circularity in steel, so how much scrap is recycled, how much steel is in fact reused, we arrive at very starkly different total market sizes for green steel. Could differ by a factor of 3 easily by 2050. So a lot of uncertainty about future market size, obviously. We'll finish up with some bit of sneak preview of our analysis and policy instruments to support green iron and steel. That's of course a very live question for the federal government, re-elected now, as well as Australian state governments, and a very live question in many countries, many other countries. So green industry policy is very much on the rise. We're seeing clearly an international competition of alternative suppliers of green iron, right? We're not the only geography in the world that is well suited for processing of iron ore using these different technologies that will be low in emissions. Middle East, Western Africa, South America, others are all well positioned to do that, obviously, in addition to the point that you drew out about China, of course. Also the factor, of course, that the sort of, I might call them the geopolitical ruptures that we've seen, especially with Trump too, are promoting more inward-looking perspectives in many countries, including major steel-producing countries, Europe, for example, potentially East Asia as well. Inward-looking in a sense of putting greater emphasis on the development of domestically based industries for physical supply security, for thoughts about securing industrial bases in a cooling international climate, and so on and so forth. And that those factors will tend to work against Australia and other resource exporters, of course. Also to be aware of a multiplicity of policy objectives, of course, right? The decarbonization objective is certainly not the only one that plays into policy design and policy choice. And finally, important questions around who bears the cost of policy intervention, who reaps the benefits, are the benefits likely to outweigh the cost from a national perspective, right? So as we're thinking collectively as a nation to deploy likely billions or tens of billions of dollars in support for clean industries, we need to be very clear-eyed about reaping the benefits from that for the nation as well. We're examining a whole heap of policy mechanisms, both on the supply side and the demand side. So what we mean by supply side is make production of green iron and green steel cheaper. What we mean by demand side mechanism is create demand for green iron and steel, even if it is more expensive. Okay, that's the fundamental dividing line that you can put on these mechanisms. We go through a whole range of criteria for evaluation. You can read them on the screen. And really that gives you a flavor of what that paper will provide, namely a characterization of a whole range of different policy instruments, right? We will not come out to make a determination as to what is the best policy instrument, right? Because there are multiple objectives, there are trade-offs, there are different features of these policy instruments, and those are the ones that governments and the community overall need to keep in mind when making those choices. Just some broad line assessments on policy instruments. The observation, firstly, that the currently dominant policy practice is supply side intervention, right? Supporting investments in green iron and steel and making green iron and steel production cheaper, okay? Totally prevalent, of course, in the US, to the extent that stays under the IRA policy. In Europe, absolutely. East Asia as well, we see that. And that's also, of course, almost the totality of Australian policy interventions in place or planned is along those lines. Make a green iron or potential or even green steel industry exist by making the cost equation more favorable. Now, for commodity exporter as we are, there's obvious questions about the fiscal sustainability of such a strategy and questions that need to be asked about the national benefit. So what's our calculation to make this support work, not just to help decarbonize the world economy, but to help bring national benefit to Australia. So in other words, how will this industry repay as a whole and over time the subsidies or other support elements that will be provided? Conversely, the creation of a sustainable framework to enable a green iron and steel industry will lie in creating demand, right? And so emissions targets in steel producing countries will tend to promote a shift to green, right? Green production in other countries, but also, they will put an advantage towards the importation of green iron, for example, from Australia, right? And so, the next set of emissions targets that will be forthcoming on the Paris Agreement, 2035 targets, will be important if we see Korea, Japan, other countries take on more ambitious targets that will help shift the balance more towards outsourcing those emissions-intensive processes like iron making to other countries, and that will help give a leg up to green iron industries in Australia and elsewhere. Secondly, carbon pricing plus border carbon adjustments in steel producing and steel using countries can be seen as a long-term viable solution to provide that green premium in markets that will be needed to bridge the cost gap between green and grey production, and the border carbon adjustment component really important to help promote import demand for green iron and steel, and not only to promote carbon low emissions processes in steel producing countries. And finally, of course, a role also for measures such as product mandates, government procurement, and corporate sustainability goals. They can all have a role, in particular in the early stages of an emergence of a green iron and steel industry. Okay, so thanks very much, and really looking forward to conversation.
Yeah, thanks very much, Frank. That was also outstanding. And please join me in giving Frank an online applause. And Frank, you'll have a moment just to scan your eye over a few of those comments. A lot of them in the Q&A box. And I'll also encourage everyone else to keep putting your questions into there. I'm just going to start with one comment, and then I'm going to ask a question to Jorrit. Just a comment is that, of course, all of the decarbonising technology platforms are under ongoing evolution, and these include things like the ESF that there's been some discussion on, but also emerging hydrogen production platforms, emerging CCUS platforms. All of these are evolving, and what you've seen today is really the first version of scenarios and analysis that HILT has been doing, and as we go forwards, we'll be continuing to develop and analyse scenarios that include these new evolutions in technology and where they may come, as well as policy. So while Frank is scanning some of those, I'm going to ask Jorrit, please, to start by giving a bit of a comment on the ESF technology. There's been a lot of different questions on that, and rather than maybe picking one, if you can maybe give us a bit of a comment that responds to a number of those questions on ESF and what you've been assuming and where you see that going. Thank you.
Yeah, so thanks. So on the electric smelter furnace, there's a comment on a plant in New Zealand. I'll get to that in a second. In Australia, there's a couple of projects underway. There's a very small pilot project in the Pilbara being built by Fortescue. And there is a consortium of players, BHP, Rio Tinto, and BlueScope, that are building I think it's about 50, 60 kilotons of production capacity per year in Quiwana. I think those should be considered sort of technology testing facilities. We're not at the scale of commercial production with that technology yet. I did see a note in the comments on electric smelter furnaces in New Zealand. I've looked that up. I would say that is a bit of an odd plant setup, actually. They are using a even more carbon intensive process than the blast furnace. So rotary kilns to do the reduction, and then electric smelter furnace. That's a very peculiar setup. I'm not sure how much of that would translate or would help with decarbonized pathways, but interesting to note. I was not aware, so thanks for that. And in terms of how far away are we with scaling up, that's a very difficult question to answer. I think the development of these kind of technologies, to put a number in terms of years before we get to commercial scale, is just about impossible to answer. What I will say is that the electric arc furnace route is clearly the more matured route at this point. However, if we really look at the very high grade of iron ore that is required via that route, there's only a very small percentage of iron ores in the world suited for that. So that's a second reason. It's not just Australian iron ores that do well in that route. It's a whole lot of global iron ores that do well in that route.
Yes, absolutely. Thank you, Jorrit. I guess we would also be seeing that kind of magnetite is the path to hematite, in a sense that the industry will probably start with magnetite, but we need to continue to develop these. I'm going to hand over to a question, please, to Frank. Frank, there's some questions there about the level of government support for technology development and how you see the pros and cons, what's happening, what the opportunities are, and what the also maybe other needs might be in that context. Thank you.
Yeah, it's a really thorny one, isn't it? Because, government support for specific technologies always risks kind of backing the wrong horse. And so, from a good economics perspective, you want as neutral as possible a framework, right? Technology neutrality, just as you emphasized for the HILT overall before, also for government technology intervention, right? Provide the support, but not necessarily make the bet as to which technology will be best. Now, is Australia is a good idea for Australia to support technology development for decarbonisation, right? And this depends on the product and on the particular sector. For iron ore processing, the answer may well be yes, right? Because we have such a big stake in the game and such enormous economic benefits from selling the iron ore that exists in Australia, and thereby a vital economic interest to, do what we reasonably can or cost effectively can to help secure the future of those iron ore export prospects, right? And that's in particular the case with the fact that iron ore grades and types differ between different geographies in the world, right? And Jorrit's work draws out very clearly the importance of smelter technology, right? And so that's a particular Australian interest that smelter technology be developed and deployed at scale, right? Whether that's in Australia or whether that's in an iron ore importing country, because, on the way that we see the world unfolding now, right? Given current, expected energy costs and technology costs, that'll be the technology that'll safeguard large volumes of Australian iron ore being used, right? And so Australia thereby has a vital interest in that technology becoming viable. How much money is needed and in what form is a question that's too difficult to answer on the basis of the research done so far.
Thanks, Frank. That was great. So now I'm going to pick up on a question that's come through in a number of guises and ask both of you to comment. And I guess this draws from where the industry currently is, that hydrogen-based reduction is the closest to market in terms of the technologies at the production end, but of course the barrier is that hydrogen via what is currently commercially available is a high cost. So there's a number of questions asking around what we understand about policy measures both in Australia and internationally that may potentially lower that cost, and where we see Australia and also other parts of the world, what they're doing, and where you see those policy measures sitting to favour different countries or favour the reduction of hydrogen cost. Maybe, Frank, you can start with that, and Jorrit, we also welcome you to comment as well. Thank you.
Yeah, so major component of cost component hydrogen production, green hydrogen production, is renewable electricity, right? And so how do you make renewable power cheaper? Well, further reductions in equipment costs. That's out of Australian hands, right? In terms of future prices of solar panels and wind turbines. What is to an extent in our hands is the installation costs, right? And so labor costs factor into that, degrees of automation, regulatory requirements around how that's deployed. That's the energy side of things, right? And then, of course, you have the electrolyzer and hydrogen storage type side of things. Again, that's capital cost, equipment cost, electrolyzers. You would confidently expect that electrolyzers will get cheaper with larger deployment, right? There may well be a case of specific investments in specific manufacturing installations, right, to really drive the cost down for specific projects. It's a bit of a chicken and egg thing, right? The first project will help the second and the 100th project to be a lot cheaper, but it will always be the most expensive project, right? So that's certainly a factor. And then there's operational cost, right? And with a country with really high wages and often really remote locations, is not low on cost scale, right? So we got to make the most of our natural advantages in terms of high solar irradiation, good wind speeds, low land prices, good port availability, in order to overcome some of the inherent cost disadvantage that we have relative to other suitable geographies.
Thanks, Frank. Jorrit, would you like to add to that or other comments?
Yeah. Just a little bit. So, I mean, my work was mostly on the international competitiveness, and I think important to add that, it's true. The bigger the deployment of these technologies we see, the more prices will come down. But that's sort of a global factor. So if China decides to go very hard on the build out of electrolyzers, that will benefit Australia as well. The cost of that equipment will come down in Australia as well. So a rising boat lifts all tides, or the other way around, really. The international competitiveness can be driven by those other factors that Frank talked about. So the renewable resource that we have, the quality, labor costs which are not necessarily in our favor, and then government incentives like the production tax credit or similar.
Thank you both. I'd like to turn the discussion to emerging markets, please. So, Frank, you talked about obviously automobiles as being a prospective one, but maybe we can talk a bit more specifically around what we can see around specific markets emerging or specific policy measures that may be promoting the emergence. Because we've got to be. We know that hypothetically they're prospective, but of course there's also time taken to build the new production, and we need to reach agreements and all those things. Can you just talk us through where you see that coming, what the current status is, what the barriers, opportunities are, what's needed to kind of unlock the beginning of those markets in real terms, given that they will likely involve trading internationally?
Yeah. So first of all, to make that very clear, right, the starting point is that green steel will be more expensive to produce than conventional steel, right? And this will be so for quite some period of time, in particular, given that there is actually excess blast furnace capacity in the world, right? And so capital cost of the existing fleet has, they're already constructed, so you're just talking operating costs. And that's the starting point. So you need to create that demand for green commodity, for green steel, at higher cost points than the grey high emissions alternative, right? Now, the straightforward way for that is to put a carbon penalty on the emissions intensive alternative, conventional steel. Now, on the existing cost differentials, right, that required carbon penalty is higher than the prices in the most highly priced emissions trading schemes, right? So, cost differential for green steel is well higher than the current price in the EU emissions trading scheme, right? So even with that, a cost gap persists, right? And so in that light, in the medium term, we're looking more at the creation of markets for special products, right? And really, visibility plays a big role here, right? What are the type of steel-based products where there is some kind of perceived benefit to the user or the customer of that thing being made of green steel, right? And so already, you buy an Apple laptop, it's made with green aluminium, right? That kind of thing, right, for steel. And so hence the automobile industry, as I explained in the talk before, appliances a possible route as well. But you can see the opportunities here in government procurement as well. Think, for example, in specific infrastructure projects, right? Where a government might say, okay, so we're going to use the construction of high-speed train line or something, for argument's sake, right, as a kind of a demonstration project for the use of green steel in infrastructure projects, right? Yeah, you can absolutely see that kind of thing happen, right? With sort of a demand-based subsidy, basically, right? What's of course difficult to see in that regard is for a government to make that kind of investment and then to import the green product, right? Because typically you will expect the government will want to channel that kind of subsidy to domestic industry, right? And so I think in Australia, we should not hold our breath to be large-scale beneficiaries in terms of, some other country choosing to build up a green iron steel industry in Australia in that kind of a way, right? So as our goal is to establish an export industry, and as far as policy instruments go, we're in a more difficult position there than countries where the goal is to supply domestic demand. But Gus, if you allow, I'll just reiterate the point about carbon pricing and border carbon adjustment, because it's really absolutely central. A country that has a carbon price like the EU, like Korea, for example, as well, right? And that couples that carbon price with a border carbon regime at the border, right? In other words, where it levies a carbon import penalty on product that is high emissions, right, will create opportunities for low emissions imports, right? Because those imports don't have to pay the levy, right? And that's really what you're looking for. If you're an exporter of green product, then you want everyone else to adopt the carbon price and to match their carbon price with a border carbon adjustment, right? This is extremely important for Australia to keep in mind in the nation's interactions globally on climate policy.
Look, great. Another related question to maybe both of you, but obviously the policy measures you're talking about so far are within one country or one region, and we are merging into a perhaps a more challenging globally political environment. But what do you see the potential for identifying bilateral or maybe trilateral or somewhat multilateral that can be mutually beneficial to help to overcome these barriers? Do you see any progress in any of that?
Should I? Yeah. Okay. So I think definitely the collaboration with what would normally or in the future be our key customers is very important for two reasons. One is that the investment that's required in iron making facilities and renewable energy around it is of such a volume that it makes a lot of sense to have the countries or the steel plant owners help out with that investment. The second reason is that might also make it more attractive for those companies to actually import either iron or continue to import iron ore from Australia. There's different views on this, I think. One comment, and this was from a spokesperson of POSCO, who are quite actively looking abroad for iron production facilities closer to location with good renewable energy resources, is that they are looking to produce iron somewhere else. So they're not looking to procure the iron, they're looking to produce it somewhere else. And I think that is going to be a more common, or possibly a more common way to organize these supply chains in the future.
Yeah, and I'll add it to exactly that, right? The experience in Australia, the establishment of very large-scale resource processing industries is one of very intensive interlocking arrangements with customers, right? And so that's essentially how the LNG industry was established, right? By way of long-term supply contracts, equity shares with consuming companies, et cetera, right? I would find it difficult to imagine the emergence of a large-scale green iron industry, exporting industry, on a sort of a merchant basis, right? Because capital requirements are just ridiculously large compared to available capital within Australia. So we're looking to import capital anyway. And so, and a major factor that stands against the investments is the uncertainty about future market conditions and future prices that can be achieved, right? And you can mitigate that risk by sharing that risk with the customer, basically, right? And so, it comes down to a question of foreign direct investment and all of that. And, historically, Australia is very, very well placed for that. We're very solid, stable foreign investment and trade regime, right? We're considered as stable with regard to, very low government investment risk, very low country risk factors, this kind of thing, right? And now perhaps we will also be perceived as a country that has no longer quite the extent of climate policy risk as we've been perceived before.
Okay, we're drawing to the end of our time. I'll hand over to Jenny in a moment to make a few final closing comments. But first of all, I'd like everybody online to join me for thanking both Professor Frank Jotzo and Dr. Jorat also for some fantastic presentations and really interesting discussion. Thank you all. Jenny,
thanks for that.
Closing comments.
Yes, thank you, Gus. I just wanted to give a big thank you to Professor Jotzo and Dr. Gozens for the 2 webinar presentations today, and also everyone who joined online with your insightful questions and comments in the chat. I think we're really privileged and proud at HILT to be able to facilitate research like this as part of our P3 program. And I think you can see how well it ties to our more technical projects as well, and all of the research that we're doing in those streams. So by bringing this all together, we're really hoping that this work can help drive opportunities for Australia in the green metal space. So thank you once again. We will be issuing links to this recording on our website. So if you'd like to see it again or watch it again or pass it on to friends, then you can do so that way. Thanks, everyone.
Thanks all. Goodbye.